Okay, welcome back guys. We're going to be solving another question from the chapter 3 of Meriam textbook, question 21. And we have this car that is placed on 4 individual scales, one under each tire, and the scale readings are 4450 newtons at each front wheel and 2950 newtons at each rear wheel. We need to determine the x coordinates of the mass energy or center of gravity of this car, and in the second part we have to also find the mass of the car. So obviously we are in equilibrium. We have our sum of all forces equals 0, and same for the moment. And what we need to do in here is that, so take a look at this question is the 3D questions, and let's just look at this car from the point of view of this observer looking at it here. And if we look at that, we'll see that this will be our x-axis, and we have the z-axis coming out of the xy plane toward us. So I'm going to show this as our z-axis, and we have the front wheels of the car at here and the rear wheels in here. So I'm just going to show the car something like this. So I'm going to show the front with F and the rear wheels with R. So if you want to draw the free body diagram for this one, we have the normal force on each tires, which for the front ones is, from the question we know the front wheels, the force is 4450 newtons, and the back one we have 2950 newtons. And obviously since there are 2 wheels at the front and 2 at the back, this can be multiplied by 2 just to show everything in one single force. And we have the center of gravity, you can show it with G, and the weight of the car. So looking at this, we'll see that we only have one unknown, and it's easy enough to find the weight of the car based on our sum of all forces in Z direction. This will be our positive. So basically we have 2 times 4450 newtons plus 2 times 2950 newtons, which is pretty much the force at front and back wheels. And we have the weight of the car is equal to 0. So from here we can find the weight, which will be 8900 plus 5900, and that's going to give us 14,800 newtons. So now we have the weight. Second part of the question is asking for the mass. We know weight is equal to mass times g, or acceleration of gravity, which we know is 9.81 meter per square second. So for finding the mass, we simply have the weight over g, and we know our weight was 14,800 divided by 9.81, and from here we can find the mass, which will be 1508.7 kilogram. So we found the mass of the car. What we need to figure out in here is this distance that I'm showing with green. Let's call it x, and that's the unknowns that we need to figure out in the question. So basically the x coordinate of the mass energy. So we have to figure out this x, and all we need to do in here is that do a simple moment about point F. We're going to call counterclockwise positive, and if we do that, we basically have the moment of the rear wheels. So we have the force, which is 2 times 2950 times the distance that we have. By the way, we are using the 2D shortcut that we have for the moment. I'm going to put the link in the description. There's a tutorial on the channel that you guys can go through that one just to refresh your mind if you need to. So the moment of this force, as we can see, is counterclockwise, so positive, and the distance is basically the distance of rear wheels to the x-axis, or what we have in here, 2640. And obviously we have the moment of the weight, which is clockwise, as we can see, so negative sign w, which we already know from the previous part, times x is equal to 0. So our x is pretty easy to find. We basically have 2 times 2950 times 2640 over the weight of the car, which we found in here, so 14 10,800, and we can find the x in here, which will be 1052.4. Since we use millimeter in here and all the dimensions in the question are in millimeter, what we get at the end in here is also millimeter. So yeah, that would be the answer for the other part of the question, where we needed to find the x coordinate of the g. And that's pretty much it for this one. As technically, we can treat this question as a 2D question if we put ourselves in the shoes of these little guy looking at the car from sideways. And as you can see, it's just a 2D simple question in equilibrium condition. And hope you guys find this one helpful. Let me know if you have any questions. Don't forget to subscribe to this channel, like and comment. It's gonna help me to reach out to more students. And you guys take care. I'll see you in the next video. Have a good one.